Hey, we're going to start talking about chain rule and multiple variables. But before we begin, let's review how we used chain rule from last year. Last year we looked at a composite function and we were asked to take the derivative of it. And we used a rule called the chain rule. Now the chain rule says we're going to take a look at the outside function first. And we're going to take the derivative of that. So we take the derivative of the outside. And that's not too hard to do. To get the derivative we would get f prime of g of x, and then we would multiply that by the inside function's derivative, the derivative of the inside, which becomes g prime of x. And that's our derivative. When we get to multivariable calculus, it gets a little bit more tricky because our function is not just in terms of x, but now we can be in terms of different variables. We can do in terms of x, our function could be in terms of x and y. So to do this chain rule, we do a little bit different for us. We use a different little rule for us. So the chain rule, still in terms of one independent variable, but what we're going to notice is our function here, w, is a function of x and y. But my independent variable is t in this case. Now it can also be u later on, t and u. We can do it with multiple of these. We'll talk about later on if we have multiple variables. But what this is saying is that the function w, which is a function of x and y, but x and y are in terms of t. So another way I could write w is a function of g of t for x and h of t for y. This is a chain rule because I'm substituting in. This becomes a composite function where x is a function of g, y is a function of h. So I'm substituting in. And we'll see that in a few moments. But right now, let's just take a look at how we find the derivative of this. To take the derivative of w with respect to t, and remember t is my variable here, here's what we're going to do. This is going to look very familiar to us, hopefully. We're going to take the del w del x. In other words, we're going to take the partial of our function w in terms of x, and then we're going to multiply that by the derivative of x with respect to t, because this becomes a composite function. X is being replaced with t. Now, basically what this says is, this is my outside function. The dx dt, that's what I'm subbing in for x. That becomes my inside function. And the same thing for w. We would get dw dy, or del w del y. This is our outside function in terms of with respect to y, and we're going to multiply that by the derivative of our inside dy dt, del y, the change in y with respect to t, because that's what we're going to substitute in. Now this may look a little confusing, and that is at first, but before we start though, this should look a little familiar to us. It looks very similar to our total derivative. And that's basically what it is. It's really kind of our total derivative right there. And you can see that if I multiply everything by dt, you can actually kind of see our total derivative from earlier. Alright, so let's see here. Here we have w. W is a function of x and y. So we have this, so x, which is x squared y minus y squared. But what they're telling us right now is that x is a function of t. X is equal to sine t. Y is equal to e to the t. Now, if I were to take the derivative, there are two ways I can find the derivative. We want to find dw dt using the chain rule. There are actually two ways you can do this. One is the old way that we kind of learned in algebra 2, in calculus, is I can replace them. W, this becomes sine t, e to the t, which is equal to, and if I plug that in, sine squared of t times e to the t, minus e to the 2t. And we want to find the derivative here, dw dt. And if we notice, man, this is going to be ugly. This is going to be ugly right here. So if I plug this through this, I have a product rule. So that's the first, sine squared t times the derivative of the second plus the second times the derivative of the first. Well, that becomes 2 sine t cosine t minus this derivative, 2e to the 2t. And that's very ugly to do. It's just hard to do. Now, we want to find the rate dw dt when t is 0. So if I let t be 0 now, not too bad. Sine of 0 is 0, plus that just becomes 0, minus 2e to the 0, so we just get negative 2. Now, I did this, but I'm like a super genius, okay? So I did that real quickly, and I have the answer in front of me too, so that helps a lot. But let's try the new way. For the new way, I am going to write it like this. To get dw dt, the first thing I'm going to do is I'm going to look at my functions. I am going to take the derivative of x, the partial with respect to x, but it's a chain rule. Remember, inside of x, I am putting in sine of t. So now that's my derivative of my outside, and now I'm going to take the derivative of my inside, which is the derivative of x with respect to t. Plus, and I do the same thing with my y. So now I'm going to take the partial of w with respect to y times, now I got to take my derivative of y, take its derivative with respect to t. So there are 4 things I need to get here. So let's see if we can find them. The first one, the partial of w with respect to x. That's easy enough to do. I can do this in my head. That's just 2xy. These are my outside ones, right? These are my outs. And then I want the partial of w with respect to y. That becomes x squared minus 2y. Now I do my inside derivatives. That's my dx dt. These are my insides. In. These are my outs, right? Take the derivative of the inside. I need dx dt. Well, I can look here. We get cosine of t, dy dt, which is just e to the t. And now I can just plug in everything. dw dt equals, plug in everything, 2xy times dx dt, which is cosine t, plus partial of w with respect to y, which is this x squared minus 2y, times the partial with respect to t, the derivative of y with respect to t, which is e to the t. And if we let, again, t equals 0, let's see what we get here. This is not bad to do. Cosine of 0 is 1, but remember, sine, x is sine, so this is all just 0, plus, and over here, x is sine of 0 is just 0, minus 2 times y. Well, y is e to the t, e to the 0 is 0, so minus 2. And, of course, e to the 0 is just 1. So, again, we do get negative 2. Now, which one's shorter? It's up to you. When we get to more variables, this is the one we're going to kind of more or less use and practice. And everything. So, all right. So, go on to video number 3, and we're going to take a look at some more examples here, okay? A bigger example.